Okay, welcome back, guys, to the minimum viable trouble 2 for the OBIX system. My name is Namdi, but you can call me OBIX Namdi. So this is just the documents I'm gonna guide you through. You got the Automaton statement, which is a formal document. This is a standard implementation, and this is just a README. But this is a program gonna run today in Python. Oh, Python. Do I have Python? If Python. Let me just try to Python help dash help. It should give me the help system. Oh no, Python is not installed. Okay. Python dash help. Okay, that's fine. I will just use WSL. Yes. So this now with WSL's Linux. We're gonna try Python dash help. It should be here. We're gonna run this Python module here, but we're not gonna run it now. I'm gonna just explain some key concepts here. Yep. So we're going to get a version of Python 2. So we'll go to 13. Okay, so using the document, I'm going to guide you through this document first of all. You see this document, it's really the document explaining statements, the technology behind something called state machine minimization. Yeah, so this is just a elegant solution. Exploring finite state machine, state and solution, but not related to the full concept. But in this document, I elaborate that a state machine memorization is a fundamental principle. Uh, Transforming integral state, but it's like in short, it's just like so. This is just the convolutional solution of an implementation of a system minimization. But this is just a convolutional solution. But this is the breakthrough in the document. So in layman's terms, the program A. So you have two programs, A and B. These programs are tennis trackers. Uh, uh, Tennis trackers. Program A, the conventional approach. You play 5 games for game one. So this just means in tennis we have like five five points to get to a match point. Then you decide a win. A match point is just one more point to the game end. You play 5 games, hard data, and then 0 to 15 to 30 to 40 to game. So this is game one, and this is player B. So this is just like an example of the state machine minimization algorithm. This is traditional approach. So program A is really trying to minimize the state. Say you're playing against you have a friend you're playing against you're playing against the world's best tennis player. What are you? Because I know some of you are not. But you play against this guy, player A. He plays tennis a lot. He's professional, and you are a novice. And you get angry or frustrated, just trying to beat this guy that I think is all it. So player A just says player A 15. So you play 2 games, and the tennis tracker, which is the machine that tracks tennis scores, A to 15. 15 means the first point you score. Notice how it's recorded: 0-0, 0-15, 0, 30, 0, 40, 0, and game. Game is just yes, this means 45. Because it's not 40 in tennis. But it's just the same thing. So it's not the same thing actually. 30, 40 game. Notice how the states are tracked for each pattern. But the problem is fast. So it makes the parser bloated. It makes everything recorded. So this is just like this is a careful analysis of the system. How the tennis tracker machine works. Say for example, now you got game A. Now you said now you want to play again. You want to beat the same guy. Now we're gonna get a new machine, the new tracking machine, or the program B, or tennis tracker B, the exe, to track the system. Game A is now done and dusted. I mean game one. Now this is game two. It means game two. So you got player A 0-0-0, and then B is empty. So this because I didn't score, it didn't record anything, or the machine did not start. It didn't start. It just tracked. It even tracked the 0, which is to 15. This row represents an empty transition, something known as epsilon, no transition. It just doesn't happen anything whenever he calls, because he's only tracking what is needed. It's only talking about whose calls. Hence it's tracking the machine, and that's how the algorithm works. So it's like the algorithm is supposed to no reduction eliminates the steps are really AST optimization, parser, state tokenizer parser, but it's really reducing node reduction, eliminating unnecessary road in state transition through streamlined path execution, which is the UNC normalization technique for character sets. The UNC normalization algorithm is really for character sets. Where do I keep it? Yes, that's for character sets. It's meant to track. In the last video, I think I saw it here. But it's there. So that's what it does. So this just tracks only what is needed. Imagine a parser system that does this. So this is 2. We're gonna go on 3 to do the next one. But this is just 2. MVP2 does 2 for the system, and this is basically the foundation of the OBIX system. So this node reduction strategy reduces only tracks what's needed in a streamlined path of execution. It doesn't branch off. It just only tracks what's needed. Like if does what it needs, tracks what it needs. The path optimization minimize the number of states and of this required each transition. Just think of that's just MVP 5. But it only does what it needs to do. Hence the state transition. And then 3, so structure reduce memory allocation and garbage collected overhead. It doesn't need to track, store, keep storing anything. Hence the system. So this is like a case study. This is a case study of the program. So it's a deep analysis of the system. But that's now we're gonna run the Python implementation of the system in Unix. So we got in this Python file we got interactive mode and non-interactive mode. But I'll show you how to use so this is just see this tracker. This is just a main function. All trackers, but we're gonna run this file. It's just MVP, and we'll see how we do it. But you go as code love 0. Love just means 0. But this is track base. This is tracker base, and this is tracker A tracker base. It's a class extension, but it's a score point system. But this just jelly tracker B. You got interactive mode and everything. So now we're gonna open a new terminal. We're gonna split the terminal. We're gonna so we now go to the WSL module here. So we're gonna ls we're gonna do Python. If you're interested in other artifacts, you can, but these only artifacts I will give you to show. So we're gonna try to clear the system. I'm gonna do Python tennis tracker, and you see how we get this help command. This is just a default anyway. But we're gonna try to do using now in non-interactive. We're gonna use one in interactive mode, and so we're gonna use the tracker. The tracker is tracker B, which is the optimized one. Tracker A just stores everything. Tracker A or A player Frederick from best max player. Well, I'm gonna name the player best and player 1 best player player and best player. His name is best, and then player 2 is worst. So I'm just typing the player. This player 2 is worst. And then we're gonna run this in non-instructive mode. This tracker, you're gonna choose the translation method to track it. I'm gonna just play only games 2. I'm gonna do interactive mode first, just for 2 games. Okay, so we're gonna watch it in real time. So we're gonna press enter. Oh, what am I doing? Option. That's a tracker. Tracker. Is it a? Oh, Python. Oh, sorry. The tracker is not. I'm not running. I'm not looking. So I have to find the execution of the tennis tracker. Interactive. So that's spelled incorrectly. Interactive. Interactive. dash interactive, but I don't think I spelled this right. Let me just copy this correctly. It should now work. Yes, so now this simulating a game or emulating a game. It's really player one has, for example, now we see player one is the best player. This is struck in real time. So one. So we're gonna try to. So in this case, player one's gonna win. But you know, one best score worst, best love. So point to player one. Point to player two. Point to player three. Point to player four. Point to player five. Point to player six. And player seven. Point to player five. So yeah, this is interactive mode. So now we're gonna play enter command one. So you can see the best is getting 3. It's now 30. Love. So we're gonna give now this is just love. Now the game has started. Game 1. So you play best games, but this is not the games 1. I think I did it. So we're gonna do point to player 2 now. 1, 2, 3, 4, 5. So this now match points. Yep. Games 1. And now we're gonna give 2 points. 30. So we're gonna 2, 2, 2, 2, 2, 2, 2. And then we're gonna do 5 twos. Now we'll do 1, 1, 1, 1, 1. That's 2 games to 2, 1. Now it's 1, 5 games. Now we can save to a CSV file. And now enter default tennis match. Tennis match A. Tennis match A game A. Yep. And then we quit. So we can now analyze this game history. This is a tennis match A. But it's tracking the data and the state. And you can see there's 17 points and yep. You see it's tracking it. It's recording all the inputs of that system. But it's not done yet. I think I put too much games. 2 games. 2 games require 2. Does it ever quit? Let me just see what it ever quits. I think I made it go on forever. Okay, now I can save it again. I can show history. So see, like the history, I can show it, which is what's being stored. And now I can quit it if I want to do. Let me save one more game. This is tennis match. Extended. And that is like a quit. No, it's not saved. Now quit it. Now get this file here. But you know, if you can see, it's been tracking or the 2 implementations simultaneously. Now we're gonna try to run the tennis tracker B. Okay. So the tennis tracker B is gonna do Python. Python tennis tracker. That's tracker B. Let me use the real names. What's his name? Hampton. I don't know. Hampton A. Best player. Win to I don't know. I think his name was like Alfie. I'm gonna call it win ban for like someone that wins. Ban as in I'm gonna call it V for Victor for victory. So these guys are going to win. And then Victor, and then I'll call his name Victor. And then his name is Victor, but that's his name. And then there's loser. Victor won win lose. Lauren. Leslie. And then you can run it in interactive mode, but this tracker B can run in interactive mode, but you know you're gonna track only what's needed. Interactive, like I just spelled that right. Dash interactive, and then this is Victor gonna start. So we're gonna try to get Leslie to start getting the input. So we're gonna do 2 for Leslie. 2, 3, and then 1, 4, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to just try to demonstrate the concept really. But you know, it's only gonna track what's needed, and then we're gonna try to save it. And then we do tennis tracker, tennis match. Winner Leslie, V, Victor, B score, B up, and then that's like here, and you see this here. You see how it only tracks what's needed. You see how small this file is smaller, even though we're playing more games. Because what's needed and track. It doesn't track everything. Everything. You know, I could have had the same inputs here, and this file will bloated. But look at this file. This is all the data from that one game, extended match, and this is all the data here. 29 lines here. This is less than 29 lines too, but it's the same thing. I can quit this program, but it's only tracking what is needed. If you understand what I mean, only what you need, only state and solution you are executing at that period of time, and that's how the tracker works. You can use it for tokenizer, parsing, and AST minimization, just to identify problems based on the path traversal, BFS or DFS algorithm makes in a parsing structure. But this is how the system is meant to work. It's meant to be coherent. You can use it for something like called UNC character normalization, which is like an algorithm that only like when you have a Unicode implementation of a system or an ASCII representation, and there's two character system, you can really bypass one system to use a function of other to then change the meaning and then do arbitrary code injection. This can stop that problem entirely using the character set UTF-8, UTF-16, or the other variants that exist to manipulate data or to store data. Okay. Thank you very much. This has been wonderful, but this implementation focuses on the tennis tracker implementation of that system to track tennis. But it's not just tennis. You can minimize any machine. It's not really implementation specific. Thank you very much. Catch you next time. Bye bye. Leave a like, a subscribe, and a share. Thank you.